Just just a minute, sir. I'm just is it now visible to everyone?
Yes.
Okay. Shall I start with your permission?
Please wait.
Okay. Good afternoon to all of you. This is
Please
Sunil.
wait. Please wait before we introduce you to the audience. Then you can start. So, good afternoon, all the audiences. This is the pre-lunch session. Let's join to the talk of Dr. Sunil Joshi, who's going to present on some unified integral formula associated with Harvey-Fludd's zeta function. So, welcome, Dr. Sunil. You may start.
Thank you, sir. Thank you. Thank you so much. First of all, thanks to the organizers for giving me the opportunity to just give my talk, which is based on the special function. And the talk of this the title of this talk is some unified integral formula associated with the Harvey-Fludd zeta function. So in this present paper, I'm just going to investigate a few new generalization integral formula which involving the extensions form of the Harvey-Fludd zeta function. And we also address the special cases by making suitable substitutions, and the results obtained here are in the general nature, and it is very useful in other engineering fields. So in the field of the science and science engineering technology, integral formulas are very useful because of the implementations of the relevant problems. But as we know, the several integral mechanisms have already been developed by number of persons as per the requirement. So we are also trying to contribute to develop uh, the few integral formula which is associated with the Harvey-Fludd zeta function. And the Harvey-Fludd zeta function, it is given in the equation number 1, and its integral representation it will given in the equation number 2, which create concrete by the several authors. And this is the equation number 1 formula, phi of z epsilon rho, which is equal to summation L1 to 0 to infinite z to power L n plus rho to power e, with this condition for mod z mod z equal to 1. And the integral representations which is in this form, phi of z rho epsilon rho is 1 upon sigma of epsilon 0 to infinite t to power epsilon minus 1 e to power minus pt upon 1 minus z e to power minus t dt. And it can be expressed in this form by taking it to power minus multiplying by e to power t on both the side, on both the numerator and denominator. So with this condition, so in this equal, Goyal and Lada and the Garg et al. Defined the new extensor formula of Harvey-Fludd zeta function, which is given in the equation number 3 and 5 respectively, and it is defined their integral representations as given in the equation number 4 and 6 respectively. So this is 3 equations which including the new parameter gamma of sub n upon L factorial with this condition. And then the another, it is by Gerg phi gamma z epsilon rho is equal to 1 upon sigma. This is the integral representation, sorry. And this is another by the Gerg phi phi of gamma uv. It is representing by this formula, including the one more variable over here, with the conditions gamma uv belongs to the complex number with other conditions, and their integral representation, which is defined in the equation number 6, which is in the terms of the hypergeometric function of 2f1 form, where real of epsilon is greater than 0, real of rho greater than 0, right, with the other conditions over here. So then after that, the Sharab also with others also developed a new and updated version of the beta function extensions, which goes likely in this form: phi of epsilon p new phi's in this form, with the integrations having the Mittag-Leffler functions, and which is defined in the equation number 8. And Rahman and others also have created a new extension of the Hurwitz-List zeta functions in the form of the extended beta function given in the equation function 7s. And this is phi of gamma uv. It is defined by this one. So it is in the form of the extensions of the Hurwitz-List zeta function in the form of the extended beta function. Then with these conditions over here, and for the present in this investigation, some integral formula which are given by the McRobert and Obertingers and the Loewy-Strauss gives in the equation number 10, 11, 12 respectively, which is required in our investigation. So we use this formula. This is the McRobert integral formula in the equation number 10th, and the another formula which is based on the orbitings, which is given by this equation number 11s, and the Lewis is given in the equation number 12. So we use in our investigation, we use this integration formula. So provided this condition, so here it is also recall the Harvard product of two analytic functions which are helpful in the current explorations, and this will help to able to have functions that has emerged as the product of the two known functions. So we have taken this fx and gx in this form, where fx is n0 to infinity nx to power n mod x less than rf, and bx x to power n mod x less than rg, where rf and rg are the radii of the convergence respectively, and their Hubbard product, it is defined in this form: f cross gx is defined by n0 to infinity n bn x to the power n for mod x less than r, where r is representing by this one. So we also recall the generalized hypergeometric functions with r and s, the numerator and denominator respectively, which is given by these results here. So this is our main aim to define the as we told that we defined the few generalized integral formula by inserting the extension form of the Hurwitz zeta function, which is given in equation number 9, into the integral form of the equation number 10, 11, 12 by taking some suitable arrangement into the integrand. So for the first term we have taken. So let us suppose that these conditions, real number of the epsilon greater than 0, UVC belongs to 0, rho greater than 0, delta greater than 0, and we use the integral representations, inserting the extension form of the Hurwitz zeta function in this form. So 0 to 1, this equations, and this is equal to in the results we are getting in the right hand side in terms of the 3f2 hypergeometric function form also. So for the proof, we start with the left hand side terms. We are indicating the IN and making the use of the equation number 9. So this is the extension form, extended form of the Hurwitz zeta functions, in the form of the extended beta function form. So we apply this equation number 9, this integrations, and now we are adjusting the order of integrations and summations, which can be expressed in this form. Then by making use of the equation number 10 after arrangement and simplifications, we'll get the required form. We are getting this form, summation L 0 to infinite, and this is the form. And now we are applying the Hadamard product, which we have taken in the equation number 13 in the equation number 16, and making use of the 9 and 14, we get the wanted outcomes what we required. The another theorem, let us suppose that with these conditions, we have taken the new integral formula and inserting this functions phi of delta gamma uv, and we are getting again in the result in the form of the 3f2 and the phi form, which is given in the equation number 17. So for the proof of this one, again we're making use of the equation number 9, which we have taken the beta delta p u of u plus alpha v minus u upon this one. This is the extended version of beta functions, and adjusting the order of integrations and summations, we are getting in the equation in this form, and by making use of the equation number 11, and after simplifications, we are and arranging, we are getting the result in the form of equation number 18, and again applying the Hadamard product, which is given in equation number 13 in equation number 18, and making use of 9 and 14, we get the wanted consequences. And the third theorem, let us suppose with these conditions, we inserted this one in the different form, and we are getting the result in the form of phi of gamma uv into 4 of 3, the hypergeometric functions, 4 in the numerator parameter and the 3 in the denominator parameter. So for our convenient, we started with the same sequence we had followed, and the same pattern means we are adjusting the order of integrations and summations. We are getting the result I3 in this form, and then afterward, by making use of the equation number 11, and after simplifications, we are getting the result in this form of 20, and again we are using the in this complete investigations, we have used the similar pattern with the different integrations. We are inserting the functions in the different integrations, and here now if we use the Hadamard product, the same the property here, and making use of the 9 and 14, we get this result. So equation number so theorem number 4, we have taken the integrations form 0 to 1 theta of tau minus 1 minus theta of 2 epsilon minus 1 minus theta by 3 2 tau minus 1 minus theta by 4 tau minus epsilon minus 1 into we inserted these functions over here, and getting the result in the form of the beta functions, Harvey beta functions, and 2 of 1 from product of 3. So we use these conditions over here, applying this formula. We have taken we are using the formula phi of delta gamma uv of this one. So we use this formula over here. We are getting the result in this form, and adjusting the order of integration and summations, we are getting in this form, and this once we are getting in this integrations form, we use the standard result, and that is in this form I4 by using the equation number 12, and for the simplifications and rearranging the terms, we are getting the equation number 22, and finally applying the Hadamard product in equation number 12, and the same process making use of 9 and 14, and equation 9 and 14 you can see here. I'll just go through the 14 equation is this one, and equation number 9 we have taken this one phi of this is the Hurwitz zeta functions, extension of the Hurwitz zeta functions in the form of the extended beta functions. So here just So we are using this one product, we are getting the result. And the another form of the integrations we have taken in the theorem number 5th. So we are getting the result in the form of the product of the three functions, beta functions, extended Hurwitz-Leach functions, and 2 of 1 form. When we inserted this the extended version of the Hurwitz-Leach functions in this integrations, and we are getting this the result in this form. The same pattern we are going to follow. We have taken these integrations using the proper definitions of that function and adjusting the order of integration summations. We are getting in the form of this one, and again these results we are getting the standard forms by making the use of equation number 12, and further simplifications and rearranging the terms we are getting the result in the form of this one I5 2 by 3 and this one. So these are the results we have taken over there, and some special cases we have also defined. So in these sections we are going to find some integral formula by substituting the particular values. So if we put the delta p equal to 1 in equation number 15, 17, 19, 21 and 23, and then we have our result in the form of the Hartman product of the Hurwitz-Leach zeta function, which is investigated by the Gerg et al. And with hypergeometry functions which are defined in the following corollaries. If we put these results equal to 1 in equation number 15, and we have the corollary as below. So let us suppose real number tau greater than 0, real number of epsilon greater than 0, gamma uv belongs to C and this others, and when we substitute this value, we are getting the result the 25 in this form. And you can see we are getting the 2 of 1 form, 1 1 3 by 2 1 by 2 data form. So similarly, if we put epsilon delta p equal to 1 and tau equal to 2 in equation number 17 and 19, and then we have the corollary 2 and 3 as follows in this form. So we have taken some special cases over there by putting this some switchable values of epsilon, tau, p, sigma, and something, and we are getting the result in the form of the corollary number 2 and the corollary number 3 with these conditions over there. So another in the similar manner, if we substitute tau equal to 1, epsilon delta p equal to 1 in the equation number 21 and 23, then it comes in the form of the corollary number 4 and corollary number 5 as follows in this form. So these are the results we are getting in this form, and the conclusion of this paper we are define the same process. The reported findings are general in nature and useful in the study of the science, technology, and engineering. These are the references we have used in our investigations. Although this particular the paper which I have taken, which is based on some certain integral formula, some integrals we have taken, and we are inserting the specific the functions and getting the result in the form of some other form. These are the references over there. Thank you so much, sir.
Thank you, Dr. Sunil Joshi. We have time for a couple of quick questions, either from offline audience or maybe from online audience. Let's take a couple of quick questions. Okay, so since there is no question from offline audience, can you check the online audience, please? There is no question. Okay, since there is no question, let's thank the speaker once again.
Thank you so much for giving the opportunity.
Okay, so I'll request the audience to please assemble for a photo session near a waterfall area.